Yeah, good morning students. In this video, we're going to discuss about the module number 5 basic processing unit. Under that, the topic hardware control. So in this hardware control, we're going to discuss about the control unit organization, block diagram of hardware control, and a complete processor. How a complete processor is going to be having its all one peripherals and this blocks. In detail, we're going to discuss about this hardware control in this video. So let's see about an overview. So we are going to discuss about the control unit organization and how control signals are going to be generated from a processor which is going to control the operation of other parts of the computer. And we're going to see about the categories of the control unit. In generally, the control unit is going to be get categorized in 4 different ways. Here we are going to discuss about 2 control unit which has been coming under our curriculum. First one hardware control and second one microprogrammed control. Let us discuss in detail about this in this further video. Control unit organization. In general, we are aware about that the central processing unit is going to be partitioned into an arithmetic logic unit and a control unit. An arithmetic logic unit and a control unit. These two are going to be playing a vital role in the particular central processing unit. So in generally we can say that the arithmetic and logic unit is the heart of any computing system, while the control unit is going to be the brain of the central processing unit. So the function of this control unit is to generate the relevant timing diagram and the control signals to all operations in the computer. Even it controls the flow of data between the processor and memory, as well as memory and the peripheral, vice versa. So the design of a control unit is not an unique one. It varies from designer to designer. So let us see about some of the commonly used control logic design methods which have been incorporated in the control unit organization. So in generally, the control logic design methods are going to be classified into 4 as sequence, register and decoder method, PLA, programmable logic array control method, hardwired control method, microprogrammed control method. Let us discuss one by one. First one, sequence, register and decoder method. So in this method, which uses an register to sequence the control states. A register is going to be used to sequence the control state. This register is decoded to provide one output for each state. For an n flip-flop in the sequence register, the circuit will have 2 to the power of 2 into n states and the decoder will have 2 to the power of n outputs. Example, a 4-bit register can be in any one of 16 states. Let us discuss how actually is going to be get presented over there. So as shown in the figure, the input is going to be given to a combinational logic circuit which is going to produce an outcome, and meanwhile what happened, the positive feedback is going to be fed to the memory. So it depends upon the clock pulse which is going to get triggered over there. That is the positive feedback is going to be get into the memory and that data will be get given as a previous state for the combinational logic circuit. Such a way the sequence, register and decoder method is going to be doing its function. Second one, PLA control method. This programmable logic array control is essentially similar to that of the sequence, register and decoder method, except that all combinational logic circuits are implemented with a PLA, nothing but programmable logic array. Here we are going to have a fixed AND arrays and programmable OR arrays. With the help of this fixed AND array and the programmable logic array, we are going to make the combinational circuit. By using this PLA for the combinational logic, it is possible to reduce the number of ICs and the number of interconnection wires. So let me going to discuss about this. So here we are going to have a diagram which is going to explain about the instruction register which is going to give the instruction, and the control step counter which is going to produce the signal control signals for that. The flags and conditional codes are going to specify the condition of the particular operation. So based on the fixed arrays of AND array and the programmable logic OR arrays, we are going to produce the control signal. This method is going to be very much useful for us to produce the particular possible number of control signals and the number of ICs and the number of interconnection wires is going to be get reduced by using this PLA control method. Let's discuss about the next one, hardware control method and micro-programmed control method. So as per our curriculum, we're going to have the third and fourth in the curriculum, and first and second are going to be beyond the content. We have to consider about this hardware control method and micro-programmed control method for our curriculum. Let's discuss about the hardware control method. In generally, to execute the instructions, the processor must have some means of generating the control signals which is needed in the proper sequence. So computer designers uses a variety of techniques to solve this problem. Approach used to fall into this category is nothing but the two. One is going to be hardware control and another one is going to be micro-programmed control. Let's discuss about in general about hardware control. What actually hardware control is? The control signals are generated as an output of a set of basic logic gates, the input of which derives from the binary bits in the instruction register. Whereas the microcontrolled program, the control signals are generated by an nothing but a micro program that is stored in the control read-only memory. So the hardwired or a micro-programmed control unit which generates the control signals to fetch and execute the instruction. The fundamental difference between this hardwired and micro-programmed control unit is that hardwire is nothing but a circuitry approach, whereas the micro-programmed control unit is nothing but implemented by the programming. That's nothing but an programming approach. So in general, we can say that hardwire control is nothing but an circuitry approach, whereas micro-programmed control is nothing but an program approach. So let's discuss about hardwire control in detail. The hardware control organization involves the control logic to be implemented with gates, flip-flops, decoders and other digital circuits. So if you're going to see about the image which shows an hardware control organization. So in this figure, the organization, a hardware control consisting of two decoder circuits, 4x16 decoder and 3x8 decoder, and a sequence counter, 4-bit sequence counter, and a number of logic gates are going to get present over there. So an instruction fetch from the memory unit is going to be placed in the instruction register. The component of this instruction register, under this instruction register, the component of an instruction register which includes 0 to 11 of through bits 0 to 11 and 12, 13, 14 and 15. And here the I bit, the operation code which is going to be present in the 15th bit of this instruction register as I. The operation code in the bits 12, 13 and 14 are decoded with an 3x8 decoder, whereas the output of these decoders are designed to designate the symbols through D0 to D7 to the logic control. Whereas the operation code of at a bit 15 is transferred to a flip-flop designed by the symbol I, and it's going to be connected to the control logic. The operation codes bits through 0 to 11 are applied to the control logic gates. The sequence counter, the 4-bit sequence counter, can count in binary from 0 to 15. That's nothing but 0, 0, 0, 0 to 1, 1, 1, 1. Such a way it's going to do its operation. Let's